All right, guys, this method is about how to find indefinite integral. Okay, so first, what is the definition of indefinite integral? Indefinite integral. Well, we know what's antiderivative. If the derivative of a capital F equals to lowercase f, we say capital F is an antiderivative of lowercase f. But antiderivative is the family of antiderivative, which is the antiderivative plus a big fat constant, arbitrary number. So in this lesson, we're going to find indefinite integrals. Okay, the first example I took is from is number 7. Okay, we have integral. Okay, 5 plus 2/3 x squared plus 3/4 x raised to the power 3. So for each term, we find its antiderivative, and plus a big fat constant. And then you organize the term, you get the indefinite integral. Make sure you attach a big constant. Check if your answer is right. You just take your answer, take a derivative to see if you get the original function given here. All right. The second example I'm going to show you here is that we have a product. There's no product rule nor quotient rule in indefinite integral or definite integral. Okay, so we have to FOIL this, and we get 2u squared plus 9u plus 4, and then we find the antiderivative for each. In the process, we apply the properties of integration. And what are these properties of integration? Such as you can bring the constant out, right? So that's what we did. And you organize the term. Okay? And the third example we did here is this one right here. Okay, the number 11 right here. In this case, as we just said, there's no quotient rule, no product rule. So we have to separate. We're going to take the x, divide into each term. We get 1 over x, the root x over x plus 1. And then root x is viewed as x raised to the power half, and subtract the exponents. So we basically get x raised to the power negative half. 1 over x plus x raised to the power negative half plus 1. And we're going to find the antiderivative for each. Okay, the antiderivative for 1 over x is ln absolute value of x. Please don't drop the absolute value. The antiderivative of x to the power negative half is we apply the power rule. So that's what we got for the antiderivative. Antiderivative 1 is x, and plus a big fat constant. So near the end, this piece, well, this part is done. And this part equals half, and 1 over 1/2 is 2. So that's the answer. Okay, let's look at another example, say number 15. Okay, number 15 for indefinite integral. Okay, we have a 2 plus tangent square theta d theta. Okay, don't forget the d theta dx. Okay. Antiderivative of 2 is 2x. But what's antiderivative of tangent square theta? If you look at the table, we don't see a tangent square, right? In these indefinite integral table. So what can we do? But we actually see there's a secant square. Okay, is tangent related to secant square somehow? I think so, because 1 plus tangent square theta. Okay, that's one of those identities is secant square theta. We can use this identity to replace tangent theta with subtracting 1 on both sides. So tangent square theta is equals to secant square theta minus 1. So we can use this relationship by replacing tangent square, excuse me, by secant squared minus 1. Okay? And next, you don't have to show this part. Okay, you don't have to show this part. And then what do we get? We're going to organize the term a little bit inside. That's going to be 1 plus, right? 2 minus 1 is a positive 1. And the antiderivative of 1 is theta. Plus the antiderivative of secant squared. What's antiderivative of secant squared? Tangent. Okay? Tangent. So tangent theta. Plus a big fat constant. We're done. We're finished. All right. Last but not least, I wasn't planning to do a lot of even numbers because I won't be putting them on the exam, but just do this number 18. Okay, just do this one number 18 because it's going to be a quickie. Okay, so this is going to be sine 2x over sine x dx, indefinite integral. For indefinite integral here, right? We need to we can apply the identity relationship because sine 2x equals to 2 times sine x cosine x. And there we go. We reduce the sine x from the numerator and denominator. So sine x and sine x, these are gone. So we only have 2 times cosine x left. And then the antiderivative is straightforward, right? Leave out the 2. Leave out the 2 outside. The antiderivative of cosine is sine x. Okay, and plus a big fat constant. Finished. Thank you for watching.